mechanic science release to service. So we're starting moving to the runway, and something happened here. That's the engine problem. Pilot opens documents, and pilot says, no, do you know what? I'm going to return to gate. We call it ground turn back. Now, sometimes I'm just using general terminology here. In the whole, by the way, in the whole presentation, I'm using general terminology, okay? So what does it mean for, you can see some company uses return to gate, right? Which is okay. But as I said, I'm using here only general terminology. So let's call it ground turn back. Next phase, let's say something happened during takeoff. And pilot says, no, I'm not going to take off. We have an engine problem, as per our documents, as per our papers. We call it aborted takeoff or rejected takeoff. Next, let's say something happened during climb or maybe the part of the cruise. And pilot says, hey, you know what? Again, let's say engine problem, right? And pilot says, I am returning to my origin airport, my departure airport. We call it and turn back. Okay? Or let's say something happened again. We had the engine issue, right? And pilot says, hey, do you know what? My origin airport is too far. My departure airport is too far. Okay? So, but I need to land the first suitable airport. And we have here E, emergency airport. We call it diversion. Okay? Let's say something happened now during approach or landing or descent. Or we have our second attempt here. We had to go around. Okay, we are good. And we call it abnormal landing or abnormal approach. Okay? Next, let's say, so we landed, everything was okay. So we have now problem, again, engine problems, let's say here on the ground. Okay? We call it general ground interruption. Okay? Now let me summarize. I'm going to put here the table. So under mission interruption ground, we have delay, cancellation, AOG, technical out of service. Under mission interruption flight, we have ground turn back, rejected or aborted takeoff, and turn back, diversion, abnormal landing, abnormal approach, whatever happened, and whenever happened, excuse me, and general ground interruption. In real life, we can have more items under each group. Not only this, we can have more groups. Okay? This is the groups that we try to focus. We said, right? We're gonna focus these primary frontline groups. Okay? So in real life, we have more groups or more subgroups. As a matter of fact, I didn't put here the in-flight shutdown, engine in-flight shutdown, and then almost all AAA, aviation authorities, they are asking to report engine in-flight shutdowns. Okay? So how many you have? 1, 2, 3, 4, 5, 6, right? You can have 12, 15 items. And you have to report it to the government. You have to show to your management. Depends on experience, as I said, it depends on the aviation authorities' requirements. Okay? You can have more items. And even more groups and more subgroups. Now, how those items are connected with our reliability program? We need to answer a question. This diversion, let's say here, let's put this circle here, right? The engine. This end turn back, this ground turn back, this landing, right? Oh, excuse me, abnormal landing was due to mechanical performance. What is the root cause? Let's say we had here engine high vibration, and pilot says, I'm going to land here. We had diversion. First, what we have to do, definitely we need to fix the problem, right? And the mechanic arrives, and then they did the troubleshooting. They say, hey, do you know what? These fan blades are not correctly installed. So either they're installing a new one, or they are installing proper way, they're fixing problem. The problem here is actually that we need to understand why these blades were not properly installed. Why? Because we don't want to see this problem 50 minutes later, here, 50 days later, 50 weeks later. We don't want to see reoccurrence. This is very important for us to fix the problem. So we need to do the root cause analysis. We need to identify either it was problem with the procedures, or maybe mechanic was not properly trained. So we need to train the mechanic. As I said, we don't want to see that the problem in 5 minutes or in 5 days or in 5 weeks. We need to reduce the risk of reoccurrence. And fix it again, let's say what, last 5 years, the next 10 years, so everything was okay, no vibration, nothing. Okay, follow up again, and we need to check see what I put here, corrective action effectiveness. Okay, so we need to train. Let's say that it was problem with mechanic, right? So all mechanics now, before they go to replace the blades, they are trained properly and they are signed paper that they know what they are doing. Okay, by the way, we are still in part 1. Okay, sorry. That's how these items are. Reliability program and mission interruption groups items are connected. Okay, same story with the safety program and reliability program. Now let's go to the last slide for part 1. I'm going to put some summary here, just again for better understanding. And I call it extracting information. So what information we need? Because at the end of the day, as I said, our reliability program shows the picture, okay, per given time period from December 1 to December 31st. Anyway, everything starts from flight and ends with flight. This is how we are making our money. On the top, we have flight. What information we are looking for from flight? Aircraft utilization. Flight hours, flight cycles, calendar time. That's exactly what gives us our statistics. It's very important. Let's say December 1, December 31st. Let me explain. 2 operations. One operation business aircraft, another operation commercial aircraft. For business side, you can see per one aircraft, per 1 year, 400, 500, maximum 700 flight hours per one aircraft per 1 year. Now, if we go to commercial operation, we can see 400 hours, flight hours, per 1 month per one aircraft. Okay? What information we are looking for? Definitely aircraft system LRU. From aircraft side, we need to know model, serial number, registration number, quantity, etc., etc. Now, why I put quantity? It's very important. Let me explain here. Let's say we have 10 aircraft. But in December, maintenance department says, hey, you know what? We need to send 1 aircraft in hangar for maintenance. So we have technical auto service. Now, how many aircraft we have now in service? Now, we don't have 10 aircraft. We have only 9 aircraft. 1 aircraft is in hangar, technical auto service. Okay? 1 aircraft is not available. Now, let's go back to our technical event side. if we had this technical event, let's say let's go back and then take this 1250 point, right? What question we asked? Okay, this system, AC generation system, is functional or not functional? As I said, under AC generation system, which is 8824, right, which is electrical system, we have AC generation system. We have DC system also, right? But let's take the exact example, this 1250 point. We talked about AC generation system. So AC generation system failed to connect. Next level is we did the troubleshooting, right? And we identified that, hey, after troubleshooting, we found that this generator failed. Now let me explain here. I'm repeating, but I'm gonna repeat because this is very important. So as we said, we have a lot of LRUs under this AC generation system, right? We have AC generator, we have generator control unit, we have different types of protection units, etc., etc. What is the reason to have all these LRUs on our aircraft? And the reason is one and only one: safety. Okay, if item is not working, if AC generation is not working, then aircraft is not safe. It means that system is not working and aircraft is not available. Okay, I'm gonna now give you another small example. So we have here two parts. One part is GPU generator, ground power unit, which is ground part. Another part is aircraft. We have auxiliary power unit generator. So APU generator we are using when we are on the ground. Okay. PCB, it is printed circuit board. It controls all these AC, DC generation systems, and FC is fuel computer. Okay. Let's say 1 hour 30 minutes before takeoff, mechanic arrives, connects GPU generator, so everything is okay. Service, they are conducting fuel system services, water system services, everything is okay. And 20 minutes before takeoff, pilot says, hey, you know what, I'm gonna now turn on APU and then connect this APU generator system. Mechanic says, okay. And the pilot turns on APU, switches from GPU generator to APU generator, and we have glitch. Okay, we can have here software glitch, we can have here hardware glitch, we can have here electronic glitch. Within seconds, we see a pilot sees next message: fuel computer power problem. Okay. Now again, mechanic takes the books, troubleshooting manuals, troubleshooting documents. The tricky thing is individually AP generator is working, PCB is working, fuel computer is working, and you still can have this message, which is a system level issue now here. What mechanic is doing? Circuit breaker reset. Sometimes helps, sometimes does. If it does help, go to the aircraft level. Power off, power on. Okay? If it does help, the mechanic does additional troubleshooting. And its outcome, as we said already, can be either delay, cancellation, or AOG. Definitely nobody, no fuel, no flight, okay? So we need to fix the problem. Where this information goes? You're right. The reliability program. Okay? This was last slide for part 1. So now let's move to the part 2 and try to build our reliability program templates and sections.